Hi everyone, I'm going to talk on a problem faced by one of the companies. They have 4,000 employees, and they, every year they observe 15% of their employees leave. So, which impacts their obviously the finance portion of it, and also it costs a lot of other overheads, and you need to train the new employees and all those things, and also the experienced people leaves, and it impacts the current running projects. So the dataset that was given an in time, out time, and different attributes of the employees, like what is the experience level, and also like how many years they are in this company, and how many years with this current manager, in which department they work, gender, all those things, all those different data are provided already. And also just job satisfaction level, and distance of the office from home. So all those things are work life balance parameters and all are there. Since the outcome is a yes or no kind of attribute, which is the attrition, I mean the company, the employee leave or not, which is a yes or no. So, and which uh, is a which is a kind of characteristic kind of variable, and in this case we'll be using the logistic regression to find out the best set of attributes which impacts the attrition. So we load the data, we load all the required package, we load each of these files, and then what we will be doing, we have to do some data cleanup, and data preparation is required. So you could see here we are doing the in and out time, we are merging those data, and we have to find out the attendance duration, right? And then we will be doing some aggregation so that we can have relevant data, meaningful data. Then we merge all those parameters based on the employee ID, which is a unique across all the files, right? And then few other analysis is done, univariate bivariate analysis is done. um, Also few other data set we require, I mean few other data set has to be derived from this data, so that we can have some plots um, for the univariate bivariate analysis, right? Post that, what we will do, we have to do some scaling of the data, because there are a lot of continuous variables are there, which requires due to different kind of units each of them are having. Scaling is must here. And also if any variables which are missing, we have to take care of those things as well, right? And we have to see the which are the unique parameters, the parameter which did not change throughout the file. Once those things are taken care, we have the final data set. We also remove the parameters which did not change throughout the file, unitary values, right? And after that we have to, we will be we are have divided the file into training and test data sets, and post that, we put the file into the GLM method, and we'll have the model one. Then and we also will be using the step AIC, so that it can help us make the process faster to find out the most important attributes. And we keep on removing the attributes which are less important by with respect to the p values and the VIF. VIF is nothing but the multi-collinearity factor in this case. And as we go down, we could see that uh, model 12 gives us the uh, final set where the p values are good in this, for these attributes p values are less than 0.05, and also multi-collinearity is not there. Once that is done, we also see if any other way we can see more collinearities and all. So we did not see much collinearity at all. Then once that is done, we have to find out whether how good is the final our model. We have to validate with the test prediction, test data. And test data, in this case it's a value which, based on which you have to find out whether the employee will leave or not. So we are taking the cutoff value as 0.05, and we are seeing what are the confusion matrix B, but we have to find out the optimal one. So here in this case calculating the optimal probability cutoff, you could see here we are doing that. And once that is done, we are the purpose is to get the good accuracy, good sensitivity, and good specificity in this case. And once all things are done, you could see we got the good accuracy, 0.73 sensitivity, and the specificity is 0.74, which is good and is optimal one, I would say. So ultimately the value comes here in this case is 0.169. When the test prediction is above 0.169, that means the attrition is yes, otherwise attrition is no. Thank you.